Geometry is one of the single biggest factors that's going to affect the edge cutting retention or durability of a knife. And I wanted to show that using this predictive CATRA equation I have set up inside of Google spreadsheet. So the predictive CATRA formula can be found on knifesteelnerds.com, and it was written by Dr. Laren Thomas, of course, who runs Knife Steel Nerds. This is back in November of 2018 in the article titled Which Steel Has the Best Edge Retention Part 1. And so Laren was donated almost 2 decades worth of CATRA data, which he was then able to build a regression formula for that. And the regression lines up well with this data. And so here we could see the actual formula. And so TCC in millimeters. So it's telling you in millimeters, total cards cut. That's what that stands for, because CATRA will cut the silica impregnated card stock. And so it's giving you a measurement in millimeters at the end there. But as we can see here, what we have here is a table showing us these different carbide volumes of different types. And you have different coefficients here that you would then add in. And so if you know the carbide volume of the different types, you could plug that into this equation here. And then you can manipulate things like edge angle and the hardness Rockwell to then kind of see how things kind of sandbox and line up with each other, which makes this very interesting. So excellent work by Dr. Thomas. Again, this was back in 2018. This probably slipped by most people, but this can be used as a very powerful tool for comparing things. And you can see right here, I have the equation down here. So for this right here, we can plug in anything we want here for hardness and edge angle. And I just want to go ahead and I want to show you guys what happens when we do such. So here we can see at the very end, the TCC is total cards cut for CATRA. So the higher number for that means that you've cut more cards at the end of 60 cycles of cutting. Everything goes to 60 cycles of cutting, which means more cards cut means it's cutting more cards throughout those cycles, meaning it's staying sharper and sharp enough to cut more of those cards, meaning it has more edge retention. And those are silica impregnated cards. And we could see that the M390, despite not being the hardest, is cutting the most cards, but we could see it does have a very hardy complement of carbides with the vanadium enriched chromium carbide and the vanadium carbide there. So it's very interesting, and you can also see what makes MagnaCut so interesting is it's a stainless steel that doesn't have any chromium carbide, and it has a very small complement of the hardest carbides, which are going to be 2% niobium carbide and 6% vanadium carbide, but for this data set, those are both just going to be your MC type, and so those add up inside there like that. We could also see the 52100. We also have no carbide for that one. Those are just iron carbide. Now they are chromium-rich iron carbide, which are slightly harder than your regular iron carbide, but we're not going to worry about that. There's no coefficient for that because iron carbides are actually fairly soft, so they don't actually get a coefficient. So we can see on here, this is kind of how these all stack. The highest number wins. So M390 has the most edge retention in this data set. 52100 has the least, despite the fact that it's fairly hard. And I just wanted to show you guys how important geometry is right here. So this is the included angles. This is 14 degrees per side, just like I did in the testing. And I want to show you guys what happens when we go to 15 degrees per side, which would be a 30 inclusive. And already we're much closer to the Lmax in this data set just from going 2 degrees difference. So even just a difference of 1 degree per side is going to have a significant factor in edge retention, to the point where you'll have one steel overtake another, vice versa. So if you're not controlling for edge angles and things like that, and you can't always see, a lot of people think that just because they're following the bevels that they're, getting that exact edge angle at the shoulder. You can't see how it's convexing in towards the tip of the apex. So this is a huge problem because you'll see people saying that, oh, well, this steel is actually cutting longer than that steel, and this is real world. This is real world. And it's like, motherfucker, you're not counting for the angle. The geometry is the most significant part. So let me show you how important geometry is. So let's go up to a 20 degree per side or 40 inclusive angle on here. And look at that. If we go to if we're comparing a 20 degree per side to a 14 degree per side and everything else, we've now made the longest cutting steel in this data set, second to last next to the 52100, despite the fact we have more carbide volume. Now check this out. Let's say that we have Magic M390. This is Magic. Magic M390 that goes to 70 Rockwell. Even with 70 Rockwell, we're still not going to be the highest cutting edge retention steel in this data set with the 20 degree per side. So this is huge. This is important. Geometry matters. Geometry cuts. It's all about the geometry. What angle are you at? When it comes both to durability and edge retention, your edge angle, the actual angle of your edge all the way to your apex, okay, smaller than your eye could see. You can have some convexity hiding at the tip of that apex radius. That's why it's important. You need to be able to measure that. You need to be able to quantify that. Because even if we had the impossible M390, by the way, M390 does not go to 70 Rockwell. That's impossible. Just not set up that way for the chemistry. That's the quickest way you could tell somebody's full of shit if they have M390 at 70 Rockwell. You know, you're fucking wrong. It doesn't do that. But even if we had it at 70 Rockwell, 558, it's still, it's not outcutting the F5VN at 61.5 Rockwell. Because geometry is important. The lower angle maintains a smaller radius better than the thicker angle. Now, if we were looking at durability, the thicker angle is more resistant to breaking because there's more meat behind it. Okay? There's literally just more steel behind it, and that's strengthening that. But then when it comes to doling, okay, if you're having a thicker angle, it's easier for your edge apex radius to get wider when the doling and wear start to happen at your edge. So geometry, 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 boys. So remember, if you're going to be trying to test something, you need to quantify edge angle. That's fucking huge. All right. Now, day-to-day use, things like that, I'm not saying you need to do that for that shit. I'm not saying you need to pull out your goniometer and, oh, I can't use, Sean said I can't use my knife unless I use my goniometer. Oh, man. Oh, I just want to use my knife so bad, but I can't because Sean said I need to get the exact angle. Oh, don't be a fucking idiot. I'm just trying to point this out because unfortunately you have people in the knife community that are trying to say that, oh, in my experience, or, oh, in my real world testing. And it's like, motherfucker, you need to account for that edge angle if you're going to be trying to compare anything. So there we go, guys. Hope that helps. Thanks for watching.